So officially now, welcome everybody to the May Meetup. We have two talks today, and the first one is by Robert Radestock about Go tools dependency management. And please, Robert, the stage is all yours.
All right, thank you. Okay, so I will give a talk about Go tools dependencies, and hopefully there's something new in here, maybe for the people who didn't use Go for that much time yet. So let's go first. Who am I? My name is Robert Radestock. I work at Spark Networks since a bunch of years. It's more than 5 now. And I started messing around with Go about 2.5 years ago. And that was at work for a work project, and I'm still at work with Go. So what are we talking about today? What are Go tools? What am I referring to with that? Go tools are code generators that are written in Go. And Go people like to use code generators because they're very, very, very helpful. Since we don't have things like generics, code generators can help us out to come up with some quick stuff. What's the problem with those? If you have external packages,
There's a request for you to speak a bit louder.
Okay, all right, I'll yell in the microphone then. So what are Go tools? Go tools are for generating code that are written in Go, like you see your examples, gogen, which is used for creating mocks of interfaces that you can use for writing tests, or goagen, which is used for generating HTTP REST APIs from some design file. Now, what's the problem with these things? Usually when you have a dependency to something, an external package that you import, those dependencies get managed by your dependency management, like Go modules if you're on newer versions of Go, or dep if you're using an older version. But now, who is managing the Go tools? Because they usually do not occur in your import statements. So they are kind of next to the project, or your project is oblivious to those versions. Now, just as a side note, continuing with this slides, I am assuming that we are vendoring our dependencies because we all love stable and reliable builds. All right, now that we got the preface done, let's dig into it. First, I'll show you an example, really how it looks at so we can see the issue, and then we discuss the issue, and then I'll show some fixes. So first, there's a heavy-handed approach that you might use if it's something urgent and you can't change anything about the project structure. And then we'll see a solution for dep and one for Go modules. Finally, if we have set up everything properly, we'll see how to use those managed dependencies then. Okay, let's dig into the example. So here we are going with gomock. As said, gomock is used to create mocks from interfaces, so we can use them for writing quick tests. And the installation instructions on the websites were like I'm showing them here. Those are slightly outdated, so they show something different, but they are pretty, let's say, symptomatic for what you would see usually on some generator README file. So here we have one line that says go get the gomock package. That's something that we will use in our code to set up the mocks. And go install gogen. That is the generator binary, and that one that's the thing that we will throw our code against, so it generates some code. Now, if we ran those things, we have a globally callable gogen binary on our machine, and that will be of the latest version. So here's some usage of gomock. Imagine the upper part is our own code. So there's some validator package. It describes this interface, and the interface has this valid method. If we throw that against gogen, it spits out the generated code below. And here we can see something already in the second line, the import statement. So as soon as we add the generated code to our repository, our dependency management will pick up the import statement, and then it will lock the gomock version to whatever is the best version, the best fit that your dependency management decides. So, okay, now as said again, mockgen is a blind spot that is not managed. So now imagine you have a new developer that joins your project sometime later. He runs the installation instructions that you have in your README, which state that he should install mockgen. If the developer does that, he will end up with a newer version of mockgen than you used back when you generated the mock files. And this is a very bad situation to be in, especially now we also have this import, which will now in your project refer to some months old version, while the mock generator that your new colleague is using is kind of expecting that it's using the latest gomock version. So the best case situation here is, or the best case issues that you get out of this is that when your new colleague is regenerating mocks, you will end up with an unexpected amount of changes. And that's something that happened in our team late last year when we got handed over an old project that we are maintaining. That's a terrible situation to be in, and you're just having a few changes that you want to make to get acquainted with the project. You regenerate mocks, and all of a sudden you have hundreds of changed files that you never even touched before, and you have no clue why that's happening. Also, kind of a best case in air quote problem that you might get is build errors, because the expectations that your Go tool has with the pinned version that are in your dependency file, they might not match and cause build issues. Worst case, you get unexpected runtime behavior, and that can be insane to debug. Right? You never know really where they're coming from. So as I said, this is an ugly situation to be in, because our project state, if we have nothing to manage our Go tooling version, our project now depends on the commit hash and the install time of the Go tools that we're using. So reproducing the state is insanely hard. How do we get out of this? So let's imagine we don't want to introduce anything new into into our project to fix this. So what we'll do is the heavy-handed workaround. Now, if we run go get, that command will fetch the full repository of something. So we can use that because now we can go back in history and align the versions. In our example for gomock, we first check out the, like, don't confuse this with the git command. We first check the version of the gomock package that is in our log file. Let's say it's 1, 2, 3, 4, A, B, C, D. If we have determined that, we now go into our Go path to the place where the mock repository resides. Now there we can do a git checkout of the version that we determined from the log file. Then we run a go install because we need the binary of the mockgen package. Then we can go back to our project, and then we can call mockgen. Okay, so this is something that you might do if it's really urgent, but it's not something that's fun to figure out. And you might have to do this for each generator that you're using, and each time you switch projects, and maybe even each time you're switching branches, if somebody decides to update versioning of your dependencies. Right? So this is insanely annoying and not something that you want to do. It's not a situation you want to be in. So let's see some solutions with dependency tooling. How can it help us out? Possible workarounds differ depending on the tools that you're using. So for dep, we have at least 2 possible ways. One is to list dependencies in the so-called required section of the Go package toml. So there you can list dependencies that don't occur in your source code anywhere, like the mockgen package. We can also tell dep to not ignore unreferenced packages. So I'll show you examples for both of these cases. And for Go modules, there's nothing like a Go package toml, so we need to convince it in some different way to pull in these dependencies. So a little spoiler: the Go modules approach is compatible with DEP, so you can use that even if you are on an old Go version. But if you upgrade your Go version, then you can easily do that and don't worry about the dependency management. I like the approach a lot, but it might seem a little weird depending on how much you dabbled with the concepts that we will require for that. All right, let's see in detail how it looks for DEP. So in the Go package toml, you can put this section just required. It's an array of packages that you can list there. You throw that in, and as soon as you run go dep, dep will load the package that you stated here in your vendor folder, and then you're basically done with that. Okay, that's pretty straightforward. And the other approach with the prune section looks like this. All right, with the way of not telling, or the way of telling dep not to exclude certain packages. So dep handles these packages sort of in a per repository base, and the gomock package and the mockgen package are both part of the same repository. So in this section, we can tell dep to not exclude any unused packages, which mockgen would be. And if we don't do that, if we just set unused packages false for that particular repository, then the mockgen code will be fetched and we could start using that. Okay, so which way is better? A is very explicit, pretty straightforward. You can see what you are requiring. For B, you don't see what you are requiring. If you just go back to the slide, there's no mention here of mockgen, so it's pretty nebulous why we are setting this unused packages to false. You might be able to guess it, but it's not straightforward. But there is a situation where B is advantageous. For example, goagen, which can be used for creating a REST API in Go. Goagen in old versions didn't state all the dependencies it needed for compiling the binary that you're using with import statements. You had to read the code because they were kind of hot wiring the dependencies. So if you wanted to use approach A, you would have to read the code to figure out all the packages that goagen itself needs. That's pretty annoying. And also you might have to worry about these things when you update the goagen versions because the project structure might change. With approach B, you don't need to worry because you're just fetching the full repository. Okay, now let's see Go modules. So for Go modules, as said, there's no way to tell it in some specific way, in some specific config file to pull in non-referenced code. But there seems to be a canonical workaround, which, so this thing is yellow because it's pointing to a GitHub issue where I found a discussion about this topic. So that's why I deem it canonical. So what we do is we reference the packages that we otherwise don't need in our code, but for generation in a special file. Let's call it tools.go. And what we do here is we put this inside the main package, so it's picked up with our main file. And we list all the packages that we need in here. That's basically like approach A of for dep. So you put in all the things here that you would have put in the required section. And notice the underscore at the beginning, that one is relevant. As we are not using the code, the Go compiler would complain about unused imports, so we wouldn't be able to compile it. But with the underscore import alias, we can make Git ignore that warning because we are indeed interested about this. Then another thing, this up here is a build tag. A build tags, you can use Go build tags to make Go ignore certain files in certain situations. And we are using the build tag here. I just use the tag tools. You can name it however you like. So that when we compile our own project, the mockgen package will not be part of our binary. So, right, mockgen is something that we do not need during runtime. This is some other binary, and we don't want that, the content of some other binary in our own project. And Go binaries are already quite big, so we don't want to drag in anything else, right? So I said the build tag makes sure that when you run go build, your binary only contains your own source code. Right, and as said, so this is just some summation of what I just said, and as said, it's also neat that this is compatible with DEP. Now, when you have this done, you end up with the Go tools packages in your vendor folder. How do we use that properly? There are a bunch of ways that you can do it. Let's see what options we have, and then yeah, we can see what might be the best one. So the first approach could be using go install. We could run go install on the vendor path, and then would end up with a mockgen binary that we can call from everywhere from our host system, which is comfortable, but it pollutes the host system. So imagine putting in somebody else's repository and they're telling you to run some scripts, and then binaries pop out and are installed somewhere on your machine. That's not something you want, especially hunting them down afterwards, right? If you want to remove certain binaries that were installed during some setup steps. So that's pretty bad. Also, you might need to do that every time you switch a branch or you switch projects. If they use the same generators, then you might have to do that. Okay, so go install doesn't sound that great. Let's see, go build. We could use go build, and that one would spit out the binary in the current working directory. That's much less pollution, so that's good. But we then might need to handle the build artifacts in git ignore, so we don't accidentally commit them. And right, I'm on Linux. I have macOS co-workers. They can't do anything with those binaries, so they shouldn't end up in the repository. Also annoying. Again, this step might need to be redone when you are switching branches. Good. Okay, doesn't sound so great. Also, here's my favorite: go run. So with go run, we can immediately we can make go create a temporary binary and run it in one command. That's pretty slick. And the temporary binary gets removed after the execution. So the binary that is created will be put in your operating system's temporary folder. That's really super. So we don't need to worry about those artifacts. Also, something that's pretty nice is that we see immediately what we are executing. Right? And with go run, we see that this is the mockgen package. If we go back, the go install and go build commands, they spit out binaries. So then if we have some build script, for example, we would have to refer to those binaries. And it's not always obvious where certain binaries are coming from, depending on how long your scripts get. So it might become quite annoying hunting down where binaries originate from. And that's also a situation that we were in. I'm quite glad that we don't have that anymore. So no host pollution, compilation and execution in one line. We don't need to handle the cleanup of the binary artifacts, and switching projects or branches is a no-brainer. You can just go ahead and don't worry about anything. Now, the last thing about this is the command up there, go run vendor github.com, golang, mockgen, is not something you want to type on a daily basis. It's quite annoying. So you get bonus points from your co-workers if you put that command in a Makefile, for example. So here's an example. First, I define a variable that's pointing to the folder, to the package. And then I have this mock target that executes the package that I defined up there. And now if my co-workers want to regenerate mocks, they just call make mock, and they're done with it. And figuring out what they're actually doing is pretty easy, right? They can look up a Makefile and they see straight away what's going on. So that's the approach that I would suggest everybody uses. It's pretty great. Right. Okay. That concludes my talk, and now we might have time for some questions.
Absolutely. Thank you very much. There were some discussions in the chat, and I guess anybody who wants to ask a question, please feel free to unmute yourself. The settings, I've changed them now, and anybody who wants to ask a question can unmute themselves. So please feel free to do this, and if there's a favorite slide, please feel free to mention that as well.
Hi, I have a question. If now you need to upgrade the version of gomock, for example, what would you actually do there?
If you needed to update versions?
Yeah, update the version of goagen and things like that.
Yeah, I mean, you could. So for dep, I would check out there are commands for dep, for example, where you run dep ensure and then upgrade, stuff like that. So you could point to a particular version that you want to use. For Go modules, I'm not so certain. We're not using that. It's been a while since I delved into that, but I'm sure there's also a way for Go modules to tell it that you want to use a particular version. Right. I mean, the updating of the dependencies is exactly the same as with the original with the code that you already are importing. I can't see the chat.
I can read out for you how to. You can also.
Up there. All right. I found the.
Okay.
I think I found it.
Okay.
Chat. Here it is. Yes. Okay. The controls switched around for me. So how to manage different package versions when on multiple projects? I mean, the projects themselves should define what versions they require. So each project by itself should have a tools.go. It sounds a little strange that there would be sort of a global dependency management for all projects. Don't know, haven't seen that yet. Right. Yeah, regarding dep is deprecated, sure is. We are currently kind of locked at 194 reasons at work, so that's why I'm still referring to dep. There might be other people, right, that you see stuff. It's not something that's unique.
I have a question.
Mm-hmm.
Is there a packet, like in Node.js, we have packet.json file to manage all the dependencies.
Mm-hmm.
Is there such a file for Go in the new upcoming versions?
With Go modules, I don't think you will see that. So in Go modules, you have a file that only tells you hash codes of packages, so you can verify that what you pulled is all right. But there is no file in which you can tell it specifically what dependencies to pull, so to say. But if you want to get an overview of what dependencies you have, you can check the sum file. Right, it's sort of right. Yeah, I'm not sure about GoMod, but anyways, if you have dependencies that you want to pull in additionally, then you can use this approach with the tools.go file.
There's some more answers in the channel, so if you want to join the conversation, you can unmute yourself and contribute as well. It's an open conversation at this stage.
Yeah, sure. Gomock basically generates a Go sum file, which contains all the hashes. And also you can specify whatever version on the go.mod, where you specify whatever version you want. And you can also use replace, which then you can replace a package version with a local instance that you have or something like that. So it's sort of flexible already.
And also, if you go get, you can go get module add a version, and it's also going to update the Go module file if you don't want to update the Go module manually as well.
So I only see one last question. The basic structure of a Go project. Well, I think there are some sort of best practices, but nothing really that you will find in, I don't know, in the Go docs or something. I mean, we have projects usually is laid out. Ah, yeah, right. That's a perfect repository there. The project layout repository gives you a great overview. Mm-hmm.
Cool. If there's more questions, I guess you can always find you on Slack.
Slack, that's a good question. I'm not sure. Am I there?
Well, if you want to join and be accessible there, you can. You're welcome. You don't have to. It's fine.
Okay, yeah, I'll join. I think I joined some Go community, but I'm not sure which one it was. Okay.
I think there's just one Slack, so it's probably, if it's a Go Slack, then it's that one.
Yep.
Cool. All right, then step one, I'll pause the recording. Welcome back, everybody, from the break. We are resuming our second talk for the day. And the talk is by Zeeshan Ali, who is telling us why does he not like Go in comparison to all kinds of languages that he's been developing with. And we'll do this the same way we've done the first talk. So now everybody goes to mute and nobody is able to unmute themselves. But you are welcome to write questions in the chat. Also note for yourself. And Zeeshan is not going to see this because it's sharing screen. But at the end of the talk, everybody will be able to unmute themselves and then ask questions and then have a conversation. Zeeshan, the stage is all yours.
Hello. The first thing I'll do is let my cat out because it will meow during the talk. Sorry for this.
I love cats. You should keep the cat with us. There's even a cat in your first slide. What is the name of your cat?
I apologize.
What is the name of your cat?
So my cat's name is Pentu. It's a Finnish cat. Oh. But the cat I'm talking about is my fiance's cat, and her name is Labriska.
Right.
Anyway, she's weird.
Back with the talk.
So yeah, I wanted to have a talk about why I don't love Go. I didn't say I don't like Go. I said I don't love Go. It's mostly. I'll first start with who I am. My name is Zeeshan Ali, as you said, and I work at Red Hat. And my background is in FOSS. I'm really sorry for this cat being noisy. For a long time I've worked with FOSS, and I love flying. I had helicopter license. I have now a plane license, and I love cats, as you know. Sometimes I also get annoyed with cats. Disclaimer from the beginning, this talk is not about bashing Go. It's about providing constructive feedback, as I would say it, because some of the things they're fixable, and Go evolves and improves over time. It's not a static language. It's not like it's like C that it's it improves like in a long time, but it improves much faster. So that's a very good thing, and that's why I want to do this talk, because if it was static and not changing much, that there won't be much point of this. But if you agree with some of the points I present, maybe you will be directly or indirectly, involved. We will be involved with the evolution of Go, and maybe it will improve in ways that finally I would love Go at some point. So yeah, that's the point. And also it's a major success story. So even if I hated it, the language, and I thought it's bad, that wouldn't be factually correct. There must be some reasons for it to be a major success story. A bad language cannot become a major success story like Go has become. So that's a credit to it. And also, I also personally believe that it's better than most languages that I've seen out there. So many of them are like bad in so many ways, and Go does pretty well. If I had to like make a list of the top languages that I like, actually Go would be in the top 5 even. But we'll talk about it more. So I said all these things, but I still don't like it. I say, so why is that? So I don't dislike it. I just don't like it. There's a subtle difference there. Quite a few things to admire, as I said, a few things already. And there are more things, like it's super easy to learn, and that's one of the reasons it has become a major success story, is because people come into a project to say Go. Actually, my first job in which Go was involved, I was presented with all the information, like this is how this works, this is how that works, everything. And at the end of the whole tutorial, the presenter just said, and Go you can learn on the go. And that was the only part about Go. So, and it's pretty much true. So that's a major credit to the language. And also async programming, asynchronous with the threads and all that. It's super easy with it, and you have like built-in features in the language that make it simple from the very start. And one of the best garbage collectors I have known in the world. So again, what's the problem? Some background before I can tell you why I have some problems with Go, which will make you understand, help you understand. So first of all, I started my career in 2001 and from the very beginning, it was about C, it was about assembly and embedded systems. And when I say embedded systems, I mean something like Intel 8051. It's microcontroller, which has, I think, the first one had 128 bytes of memory, not K, but 128 bytes of RAM. And then the more advanced version had 256 bytes of RAM. And it was, I think, I don't know how many megahertz was it, but it wasn't a lot. So it was really, really tiny space to fit anything. And even C was sometimes not the right language for the task. You do mostly in assembly. So I started with that. So from the beginning, I had this desire, and I had this mentality to save space, to save resources the best you could. So I continued with that. I wasn't always working with embedded, and even when I was, not with like something so extremely constrained. But it was still with C mostly, and so my background is mainly C. And other languages along the way I learned and used, such as Python, C++, others, Java. But still C was my main thing. And until Rust came along, and at first I was very doubtful about the language, but then I learned it slowly, and it was ultimately something I came to love. So that's kind of like my background. So why you would ask, why would I bother with Go if I don't like it and I have other choices and there are languages that I love and stuff. Simply put, job market, especially with Rust, it's still like there's not a lot of jobs out there. And I need to eat, and I need to provide for my family as well. So yeah, and there's a lot of jobs in cloud infra, and they're mostly in Go, like you have to do Go. And especially the current job I have in Red Hat is we are working on OpenShift and Kubernetes. And as you know, it's pretty much all Go, mostly. No, there are some things that are not in Go. They're in C and Rust and stuff, but mostly it's in Go. So let's get on with it already. What are the things that I don't like? First of all, safety. It's actually not a bad thing about Go. It's 1,000 times safer than C. In C, so many things can go wrong. You can easily shoot yourself in the foot. People argue that with the right API, you can make it safe, but that's like a conscious effort. You have to do it yourself. 1 second. Okay, cat's out. So it won't meow anymore. Yeah, it's much safer than C. So like 1,000 times because you have managed memory. So the Go's GC and also in some somewhat compiler as well is handling the memory for you. So you're not very likely to shoot yourself in the foot like you can do in C in so many ways. So yeah, that's a really great thing. However, it comes at a cost. As I said, I come from embedded background. So to me, the cost of garbage collector is a pretty big one. It depends, of course, on the case, right? So if you have a CI system or something like that, or some scripts that you need to run, garbage collector doesn't matter that much. And it also depends on how many systems your code will be run on. Maybe the cost is not that great, that much, depending on the use case and stuff. But in many cases, it matters a lot. So, so there is a bit of a problem there. Like it's not for free, the safety you're getting. And also at the same time, null pointer is still there. That's a pretty big danger when it comes to safety. It's not as bad as in, for example, C and C++, that if you dereference a null pointer, you will get a crash and stuff like that. But you still get a panic, a runtime panic for it, and people can still misuse this to cause DDoS attacks and stuff like that. So it can be misused. It is a problem for safety. And then we come to the what annoys me on day-to-day basis when I would code in Go. One of the first things that comes to my mind is enumerator type. In C, you had, like from the beginning, I think, I had enum type that you can create for. It's especially used for flags and bit flags and stuff. But it's a very simple thing, but in a lot of things, it's like that's what you want to use. Like you have many different kinds of variants for a type, and enum would be the most natural choice for representing it. Sorry, like for example here, that's the most natural choice. And Rust brings it to a new level. You can have complex enums with fields and named fields and stuff like that. So I got spoiled with that. And in Go, you don't have enums. You can emulate enums, but you can only emulate C-like enums with constants and type aliasing. But it's not as on par with what I got used to with Rust. So it kind of felt, when I was programming, I got used to it. So I was thinking in terms of enum. So when I would come up with a solution, it would be using enum, and then I'm like, oh, but it's not available. So then I have to rethink the solution. Then there's generics. Sorry for all the interruptions. And you know, if you have been around in Go world for a while, it's, you know, it's a very controversial topic, and many people think there should be generics in Go. Many people think no, there shouldn't be, but I'm of the opinion that it should be there because it's improved so much your life when you want to create some solutions, generic solutions. And it's not a concept in C, but Rust, it is a concept. As I said before about the null pointer, so this is a type in Rust, a fundamental type, which you use to represent something that can be something or nothing. But you have to explicitly deal with this type. You have to parse it. You have to deal with the case of none explicitly always. Or you have to tell it explicitly, okay, I don't want to deal with the case of none. But in Go, you can still, just like C and Go, just like in C, it's like pointer, you don't know. Anyway, back to the generics. So in Go, just like in C, you can do, you know, code generation. I did that a lot in C and, you know, in Go as well, but it's not the nicest solution. It's not, it's okay, you know, you can do it, but it's not as convenient as generics would be. So it's just about convenience here, I guess. Talking of convenience, macros, you have them in C. But they're very simple. You can have just like simple replacement at pre-compile time actually, and whenever you use them, the thing gets replaced and it's magic and it works. But it's not extremely powerful or useful. But it's at least it's a concept and it's there. Rust brings it to another thing, brings it to a whole new level. In this code snippet, the thing with the exclamation mark at the end, that's a macro. All macros are ended with a exclamation mark, so it's clear where you have a macro. And you can define a completely new language in this macro. So here we have a JSON macro that allows you to create JSON data in the language itself. So yeah, again, I got spoiled. So it's, but you don't have something like that in Go. Tooling, I was extremely surprised with this one actually, because Go is a much more mature language compared to Rust. So I was expecting the tooling to be really good, but I was really shocked when I, you know, it's one of the first few things you do, like dealing with these tools, like go get this, whatever. And I was so surprised that there was no interaction, there was no feedback about what's happening. Like, are you downloading something? Is there some progress at all, or was there an error or not? And then someone told me that if there is no error printed, that means everything went fine. But still, it's like, feel something is missing when you get used to tools which gives you feedback. The same with a bit related is build systems. In C, we first, you know, Makefiles have been around for a long time, but Makefiles, like for when a system becomes a bit complex, Makefiles won't cut it. So for a long time in the projects that I worked, we used auto tools. They're not famous to be very friendly at all, but they were extremely useful. Like once you get it right, it would work very nicely. And that's why recently there has been a big shift towards a new system called Mason, with which you use a Python-like syntax to create your build scripts. And it's really simple and it's very powerful and it's awesome for C at least. With Rust, it was from day one, at least for me when I learned it, there was Cargo, and it's a really awesome and powerful and very simple system to download and build things. So it's cool. But I was surprised again when I was working on different Go projects that they were using Makefiles, like of all the things, like not even you know, Mason or something like that. Yeah, again, like very surprised. And a lot of projects, like even very, very sophisticated projects that have that are very successful and they're used a lot and downloaded a lot in millions. They have like a directory called hacks, and in the hacks that you have a build. So even the name tells you that there is a problem there, you know. And so I was really surprised, and yeah, each time I have to deal with these build systems in Go, it's not a nice experience, and I really miss cargo when I have to do that. So some of you must be wondering, like, if I am so tired of Go and on my job, why don't I just quit? And actually, I did. Last weekend, I quit on my job to join a Rust company. It's a bit of a risk for me. It's a new startup and stuff, and I wasn't sure about it, but I think it's the right choice because I want to be productive. And currently, at least in the current state of Go, I'm not that productive. So yeah, I need to, right now at least, Rust is the right choice for me personally. Yeah, but at some point, I'm hoping that things, as I said, they will evolve, Go will evolve, and Go would become more powerful, have a lot more features. And hopefully at some point, I can just love it and I can code in it just like, and love coding in it just like in, you know, some of the problems you can't fix, of course, like I don't think it will ever be non-garbage collected and you will have manual memory management or anything like that. But that, as I said, that part is dependent on the project you're doing. In some projects, it doesn't matter. In some, it does. So yeah, that's it from me. Thank you for listening to me, and also big thank you to the organizers for actually inviting me to do this talk. Yeah, if you have any questions, feel free to ask.
Thank you very, very much. There are some questions or opinions, let's say, on the chat, not only about cats and helicopters, but definitely also about that. So I've changed the settings. If you want to say something or ask something, you are now able to unmute yourself. And please have a conversation.
Yeah, thanks for your talk, and thanks for you seeing or using Go more as your scripting language in your set, and for others who come from Ruby or JavaScript or so to Go, Go is the systems language in their set, and this is really interesting to see because you have a quite different viewpoint as you come from C and assembler and Rust. And yeah, thanks for that. It's quite interesting.
No worries. Yeah. But I don't, like at work, we don't use it for scripts. Yeah, I think I said it a bit wrongly. I didn't mean for scripts, but what I meant to say was that there are tasks at which it doesn't matter if there is a garbage collector or a runtime cost. There are problems like that for sure. And as for the systems programming language, I recently saw this video, very informative, of a panel of people, like one of the Rust developers, the C++ person, what's the name, Strustrup or something, and the Go creator, and also someone for C, representing C and D language. And the creator of Go, I don't remember their name, but they said that Go was never designed to be a real systems programming language. It was supposed to be somewhere in between, like not scripting, not system, somewhere in between. And it's, yeah, that's correct. I think I would put it in the same way. Was there a question on chat? I don't see it.
It's like more of a chatter.
So you said that you're not Okay. Yeah. So you said that you are not as productive in Go, right? So I was wondering if, because the type of problems that you usually work with, they show they need the things that Go doesn't have, like generics or something else, or just more because you're so used to use these features that Go doesn't have that you yourself is not productive, right? Because I work with Java, with Python, and of course we have generics in Java, but I don't really miss it in Go. I see that some stuff it could help, but most of the work that I've been doing working in startups, that's not really a problem. So I always wonder if it's just a bit of culture or people who do feel that Go is lacking something to the point that it's not really applicable for them, is because the set of problems that they solve is so different that's quite evident.
So I think, at least for me, and I have noticed the same with a few other people with the exact same background, like Rust and C, especially Rust, is that if you have used Rust once and then you start using Go, at some point, if you just only use Go and forget about Rust, there will be a shift in your mind, like how you think, how you approach problems, because you will start thinking in terms of Go. It's just natural. It doesn't matter which language it is. You'll start thinking in terms of that language naturally. But the thing is, like for me and for others, it's I do Rust in my spare time and I do Go in my work time. So when I do Rust for a while, for a few days, like for example on a weekend, I get used to thinking in those terms, in those features. Like I start making use of those features like generics and enums and macros. And then I come to Go and all of a sudden I have to think differently. So that's, for me, that's the thing. If I had like left Go Rust behind and coded in Go for months and years, I'm sure that I'll stop missing any like these features. Okay, there's more questions. What concept is Rust using to go around null pointer? So the thing is that you don't have null pointer, but rather you have an enum, simple enum type that I showed earlier. I can actually go back in my slides. Was not so far. This one. So if you look at this one, this is what Rust uses to avoid null pointer. When you create a type that could be null, you give it this type, and it's a generic type. So you can wrap anything in this option enum, and then you either create a sum if you have something, and if you have none, then you create none. And when you return this option from your function, for example, the caller has to explicitly deal with the case that it's none. It's not like you can miss it, like in Go or C and many languages. So that's how it saves it. Let me launch the chat again. Sorry.
I have like kind of provocative question right now. Would you?
One second, Michal. 1 second. There was one more thing. There was a question, how can we reach out to Zeeshan? I'm Zenix on IRC. I'll put it on chat. On also Matrix, I guess. But on Freenode IRC and also GNOME IRC, I'm on both of them. And I think I'm also on IRCnet, at least. So you can reach out to me with this nickname there. And also I had my email in the first slide. I'll go to the first slide now. Yeah, Michal, what was it?
So since you work with Kubernetes and containers or every day, would you rewrite Kubernetes or Docker or Podman in Rust?
So that's a good question, actually. Thing is, if they were to be written now, yes, of course, Rust is the best choice for those. But they were not written when Rust was ready. They were written when Go was ready. And Go, I think at that time was really the best choice to do those things. So yeah, I think that they chose the right thing. But if it was to be done right now, like for example, you have heard of Firecracker, right? It's done by cloud people who have been doing Go for a long time and stuff. And most of what they do is still Go, those tools. But Firecracker, they did it in Rust. So there's a reason for that. Like for some of the problems nowadays, Rust is better than Go.
Yeah, no, Firecracker, that's a good example of that kind of project.
Yeah. I mean, it can be done in Go too. It's not a problem.
Like, second question from me, what are your thoughts about dependency management in Go? Like, I mean, both the current way of Go mode and previous
the previous
like
way, I hated all of them, and that's what I meant by the Go tooling and build systems. So no, that was one of the things that really depressed me about Go. Like, I wasn't impressed. But in Rust, you have cargo, and it just handles all of it for you. So yeah. Can people see my video actually? Or, oh yeah, they can.
You can see your slides, the Zoom people that you have, and the chat.
Exactly. Probably we see the whole Zoom, all Zoom windows you have.
Ah, okay. Sorry. So I think that was the last question, right?
And if anything, you are available both on Twitter and on Slack, so it's always possible to send you more questions, right?
Yes.
If you want. You're never obligated to answer, but if you want. All right, cool. Then thank you very much for sharing your thoughts with us.
No worries.
And I'll stop the recording so we can upload this to our YouTube.